Hello everyone. So in this video I will actually explain the problem number 42 from 50 challenging problems in probability. The title of the problem is actually the little end of the stick. So let's describe the briefly the key questions of this problem. So we have a stick and we have to find first considering that that stick is broken in two random point, then we have to find what is the average length of the smaller piece. And the second part is much more interesting, and that is what is the average ratio of the smaller length to the larger one. So the first part actually asks us what is the average length of the smaller piece, and the second part is actually asks us to find the average ratio of the smaller length to the larger one. So let's actually explain two parts. First, the first question actually asks us the average length of the smaller piece. So let's assume that the stick has actually broken at point X. So we have a stick, and we have actually broken the stick at point X, and this X can be actually at any random point of the stick. So it can be at any point. So if the length of the stick is actually L, then the length of the second piece should be actually L minus X. So it's very easy. And so now the question is actually what is the average length of the smaller piece. So the length of the smaller piece should be the upper limit of the smaller piece should be actually L by 2, because we are actually breaking it in two pieces. So the max upper limit of the smaller piece should be actually L by 2 when the two parts are actually equal, and the lower limit can be actually 0. It means that we haven't actually broken the stick. So consider and now actually what we have to find is actually the average length of the smaller piece. So clearly if you actually find the upper limit and lower limit for the smaller for the length of the smaller piece, then the average should be actually the half of the half part, like we have to actually take the average from 0 to L by 2. So the average length of the smaller piece should be actually, if the length is actually L, then in that case the average length of the smaller piece should be L by 4. So if we actually have a unit length of stick, then the average length of the smaller piece should be actually 1 by 4. So this is the explanation of the first part. Now actually let's move on to the next part. So the next question is actually like we have to find the average ratio of the smaller length of the larger piece. I mean average ratio between the smaller length to the larger piece. So once again, let's assume that the breaking point is selected randomly, and let's assume that it has actually fallen in the right side. So if the stick is actually broken into point X, then and if we consider that it's a unit length stick, or the length of the stick is 1, in that case the length of the two pieces should be 1 minus X and X. So the ratio of the fraction should be actually 1 minus X divided by X. Very self-explanatory. So now since X is actually evenly distributed from here we have to find actually the average ratio of the smaller length to the larger part. So since X is actually evenly distributed from half to 1 by 2 to 1, so now what can we actually do is we can actually find the integral where the integral of 1 minus X divided by X to the power X with respect to dx, and with a limit of half to 1. And this is because actually if the key concept is actually the what is the expected value of of any event or any instance. So let's assume that y is equal to f of x. This y is equal to f of x. So what is the expected value of value or e of y? So the key concept is actually is the multiplication of the event with its likelihood or the probability here. So if f of x is the event and its probability is actually this part. So if we actually multiply this, then the expected value of y should be actually actually the integral of all the probable events and their corresponding probability. So based on this concept, we can actually find the average ratio of the ratio of smaller length to the larger length. Here smaller length is equal to 1 minus x and larger length is equal to x. So if that's the concept here. So if we actually integrate this function with a limit of half to 1, then we'll actually find the ratio of the smaller length to the larger piece. Now if we actually break it down, then we'll find that we can actually break it into this part. Now clearly integration of 1 by x with respect to dx is equal to ln x, and this should be easier part. So as it's a constant. So finally we can actually get the value, and that is approximately 0.386. So the ratio of so this is the answer of the ratio for the smaller piece to the larger piece. So this is the explanation. Thank you.